Section 4.1.RA-7 interactive assignment. For the following data set, in Part A we want to draw a scatter diagram. In Part B we want to compute the correlation coefficient. In Part C we're going to comment on the type of relation that appears to exist between x and y. So the first thing we want to do is be able to create a scatter diagram of the data here. So I'm going to open this up in StatCrunch. So here's my data table. I'm going to go ahead and open it up in StatCrunch. Okay, now that I've opened it up in StatCrunch, I want to be able to figure out what this scatter diagram is going to look like. So the first column is x, which is our explanatory variable, and the second column is y, which is our response variable. I'm going to go ahead and select graph, and then scroll down to scatter plot, and then I'm going to select the x variable to be x, the y variable to be y. I'm not going to worry about labeling this particular scatter diagram because we don't have anything to label it. We're going to select compute, and then if you notice, there is our scatter diagram. Okay, in Part B, what they want us to do is they want us to be able to find what is the linear correlation coefficient. And what it does is it measures the strength of a linear relation between two quantitative variables. The letter R is used to represent the sample correlation coefficient. So in order to do that, we're going to select Stat, and then go down to Summary Stats, and then scroll to the right to find Correlation. We're going to select the first variable and make sure it's present in the tab to the right, and then hit Control and make sure the Y is as well. So we want to find the linear correlation coefficient between those two variables. We're going to select Compute, and then if you can see there, we end up getting 0.888, and we round up to 3 decimal places. So R is going to be approximately 0.888. Now you can also do this by hand, which is a very long calculation. I would recommend using StatCrunch. In Part C, we want to be able to then determine, okay, what type of relation that appears to exist between x and y. Well, since we got a number of 0.88, the closer R is to +1, the stronger is the evidence of a positive association between the two variables. The closer R is to -1, the stronger is the evidence of a negative association between the two variables. And if R is close to 0, then there is little or no evidence of a linear relation between the two variables. Since R is positive and it's closer to +1, then there appears to be a positive linear association between x and y.